All right, so I need to give you guys an intro to what's called 2x2 augmented matrices. Whoa! Okay, look, it's not actually hard. It's hard to spell, but it's not hard to do. Okay? So, my claim is you guys did this in Algebra 1. So the idea is this. You have two equations. Like 1x plus 2y is, wait, I have to carefully craft this, is 3, and 3x plus 4y is, what was my, 8. Cool? Okay. Do you guys remember doing things like this?
Yeah.
Yes-ish?
Yeah.
No?
Yeah.
Maybe? Some of? Okay. Can anyone tell me what kind of thing these two guys are? They're equations that specifically describe what kind of thing? Like maybe what if you solve for y? Points on a graph, specifically a line. You guys see that? Yeah, these are linear equations, right? These are lines. Okay, so if these are lines, in general, what do two lines look like? Okay, good. There's a line like this,
right,
and then generally, right, there's some other line that might look like this.
correct.
You guys see that? This is the general case. This is what happens most of the time. It is not what happens all the time.
Okay.
You guys see that? So when I'm wondering about solving this system, that means I'm looking for this point of intersection here. Cool?
Cool.
So you guys, I think, maybe know some toys for this. Like you could eliminate a variable, or you could solve for x or y and substitute or something. Right? And you guys probably kind of rando your way through these. So what matrices are is just a way to codify this whole thing. Cool? So all I'm going to do is I'm going to turn this thing into a matrix by stripping off the variables. Okay? So this number here is going to be the number on x in the first equation, which is what? 1. Okay, I'm not writing down an x, I'm just writing that coefficient down.
Got it.
What's the next number going to wrap?
2.
Probably 2, because that's going to be the y's. Okay, so first column I'm thinking x's, second column I'm thinking y's, third column is going to be 3, the numbers. You guys cool with this?
Cool.
I'm going to separate those two with kind of an equal sign, right? So that's just for me in my head to separate the numbers from the variables. Cool? So that whole first thing is just a condensed version of the first equation. Guys cool with that? Okay, so what's your condensed version of the second equation?
3, 4, 8.
Okay, x's are 3, y's is 4, and number is 8. Make sure they're arranged this way before you do that ripping. Okay, see that? If you rip the numbers off and the things are rearranged, your columns won't mean x's, like the top will mean x's and the bottom will mean y's, and then you can't do this same thing. Guys cool? Okay, now we're going to do the same thing we would have done with the elimination method. So I'm going to look for a convenient variable to eliminate, and I would recommend that you start with this one here. Cool?
Cool.
Okay, so how am I going to get rid of this number here? That's me trying to get rid of this 3x, right? So what do I need to add to 3x to get rid of it? Yeah, I need a negative 3x, right? So what I'm going to do is I'm going to take that first equation, and I'm going to multiply it through by negative 3.
Okay.
You guys with me? So I'm going to have negative 3x minus remember, first equation, the other equation. So I'm going to have negative 6y is negative 9, right? And then I'm going to add those together. But I'm going to get really tired of writing down x's and y's, so I'm just going to do that over here with the matrix. I'm going to take this thing, I'm going to multiply by negative 3. I'm going to write it just underneath here. Cool. So this blue object, right, is row 1 multiplied by negative 3. Cool. Okay, so then I'm going to replace what?
The top row.
Close. I'm going to leave the top row totally alone. So I'm going to leave my 1, 2, 3 in the top row. And I'm going to replace the bottom row with,
What you get? Can you put those two together?
yeah, these two, right? The old bottom row and this thing I made out of the top row added together. So I'm going to get what?
0.
0,
Negative 2.
-2,
Negative 1.
-1. Guys all cool with that?
Yeah.
Okay, so now if I think back to equation land, what does this top row represent?
A line.
It represents x plus 2y is 3, right? What does this row represent? No x's, right?
Right. Negative 2y.
Minus 2y's equals negative 1, right? So that guy represents negative 2y equals negative 1. Now I know what y is. You guys see that? Y is 1/2. Cool. Now where do I get x?
Do that again for the y. Right?
Good, yeah. So I can get that 2 places. I can either eliminate this number here, right? Or I could take this y as 1/2 and back substitute it into either one of these in the beginning. You guys see that? I'm going to do it the matrix way because I just learned this trick. So what I'm going to do is I'm going to write the bottom row just up here. I got 0, negative 2, negative 1, right? And then I'm going to make a new matrix. And I'm going to leave the bottom row alone. And what's the top row going to become? 1, 0, 2. You guys see that? And that guy should tell you what? X is,
1 y.
I think I got 1x plus 0 y's is 2. So
X equals 2.
So x is 2. So my point of intersection is 2, comma 1/2. That's cool?
Cool.
Okay, so aim for bottom left first when available. You can aim bottom right first when it's 2x2s. If you start doing 3x3 systems, which we're going to do in a bit here, you want to aim for bottom left first all the time. Cool? What's up, Austin?
Are you going to ask us to completely do the matrix on the test, or are you just going to, if we get that 1/2 is y, can we just plug it in back instead of going through the rest of the matrix?
Yeah, so when you get to one of the variables known, you can do whatever you want to get to the rest.
Got it.
Cool? In the 3x3 case, I would really recommend that you get it to triangular at least. I'll show you what that looks like. Okay, so this was the most convenient possible option. Let me show you one that's slightly dorky. Dorky's not actually harder, you just have to know what to do with it. Okay, so say we had 2y is 7 minus 2x, and x plus y is 4. Can you guys turn this into a matrix for me?
Yeah. Here we go. -2, 2, 7 on the top one.
Okay, careful. Good thought, but careful.
You gotta flip
So
the
why is it
sign.
not -2 for the x's?
You gotta throw the 2 on the other side of the equal
Yeah.
sign.
Yeah.
It's got to be on the other side. So this equation, right, contains the same information as 2x plus 2y is 7. You guys cool with me? So you've got to write them in standard form first. So you get 2, 2, 7. And then what's your other one, Reed? 1, 1, 4, right? Okay? So, now what?
The bottom left.
Okay, I want to target this bottom left thing, right? Okay, how do I get to that? Multiply what by -1? You want to multiply the first equation by -1?
1.5.
So you could multiply this whole equation by -2. So there's a couple options. You could multiply the top equation by -1/2, right? And then add that to the bottom equation. Or you could multiply the bottom equation by -2 and add that to the top. You guys see that?
Yes.
Don't really care which one you do. I'll do the multiply by -1/2 because I think that was suggested first. So if I multiply this top equation by -1/2, I get -1, -1, and -7/2, whatever the heck that is, right? Okay, so then I'm going to add these together. What am I going to do to the top equation? Yeah, just leave the top equation be. So you got 2, 2, 7. And then in the bottom equation, what do you have?
0,
0, 0, 4, I think, is 8 halves, right? 8 halves minus 7 halves is 1/2. Okay, but now I have a problem.
0 does not equal 1/2.
So do you guys see that this bottom equation says 0 equals 1/2?
Yeah.
Right, that says 0x's plus 0y's is 1/2. That's not true. Right?
So that's, boom.
Lies. Exactly. So what does this mean?
Means
Yeah, there's no solution, right? Okay, when and why did that happen?
They don't.
There were two lines, right?
They don't intersect.
And the two lines don't intersect anywhere, right? They're parallel and different. You guys with me on that?
Yeah, dog.
Yep.
Okay, so that's the no solution case. There is one other option here, which is, what if I had gotten 0, 0, 0 here? 0 does equal 0, right? That would be true. So let me set up an equation like that. If I had x plus y is 4 and x plus y is 4. You guys see this?
Yes.
So 0 would equal 0 if I did this. And what's the interpretation of this? Good thought, Joseph. They're the same line. You guys see that? So where do they intersect? Where does this line intersect with itself?
Everywhere.
Everywhere. Right? So that one, you would say, circle one of these is the answer. Right? That whole line works. Cool?
Cool.
Okay. So that's the 2 by 2 cases, right?